Hello, second grade. We're going to be doing lesson 27 for math today, which is using square tiles to make up a rectangle. So you will need your papers from the packet for math. And if you have graphing paper at home, you can get some of that out. If not, that's fine too. I have some that I will use to show you everything. So you can go ahead and grab those things and we'll get started. Hello everyone, today's lesson is going to be talking about squares and rectangles. So I want to start off with looking at a square, just as a quick review of what a square is. So a square is a four-sided figure, and these figures have all sides the same length. So if you look at the top, the bottom, and the two sides, they're all the same length. So before we figure out how we know this, let's look at the sides. So we're going to go across. These are actually called your rows when we go side to side. So I'm going to label that so we can remember it. Going side to side is our rows. Now, when we go up and down, these are called columns. So the reason why we know that this shape that I've drawn is a square is because the rows and the columns are equal. So if you look at the number of squares, little squares going across, 1, 2, 3, we have 3. And if we look at the number of squares going down, we also have 1, 2, 3. So when all of our rows and columns are equal, we have a square. Now the difference with a rectangle, it's also a four-sided figure, but the top and the bottom do not match the sides. So as you can see on the one that I drew, when we count our rows, 1, 2, 3, 4, 5, we have 5 units going across. And then when we look at our columns, we have 1, 2, 3 units going down. So we know that this is a rectangle. They're not equal on all sides. So that's the difference between a square and a rectangle. A square has all equal sides, looking at your rows and your columns, and your rectangles do not. So the rectangles usually have the tops and the bottoms are longer and the sides are shorter, or you can even switch it around and make the sides longer and the top and bottom shorter. Either way, the sides aren't equal, so that makes it a rectangle. Now let's go ahead and get started with today's lesson. In front of me, I have 12 squares. So I know this is a square because all of the sides are the same length. So I have 12 squares and I made one long rectangle with my 12 squares. I know this is a rectangle because our rows and columns are different lengths. So if I go across the top and bottom, they are a different length than the two sides. So what I'm going to do now is I'm going to try to use these exact same squares and make a different rectangle with them. So I see that I have one row going across. I'm going to try to make a rectangle with 2 rows going across. So what I'm thinking is if I have 12 squares, I'm going to split them in half. Half of 12 is 6. So I'm going to use 6 squares on the top and I'm going to move 6 to the bottom. And I'm going to see if that gives me a rectangle. Okay. So let's look what I've done. I used my 12 squares and I made another rectangle. So we used the exact number of squares and we made a rectangle that looks different than the first one. Now what I want to do is see if we can figure out how to use the same number of squares like we just did, and this time make a rectangle that has 3 rows in it. So I'm going to give you a moment to think, how could we make another rectangle using my 12 squares? This time though, making 3 rows across. Okay, I'm going to give you just a second to think about it. If you want, you can pause the video. So how I would do this is I'm just going to look at it and I'm going to start taking some from this side and moving them down to see if I can make a rectangle with my squares and make it into 3 rows. So I have 3 even rows. Now I just need to figure out, is this a rectangle? So if I look at it, my top row has 4 going across, the sides have 3 going down, so this is a rectangle. So we have shown now that we can use 12 squares to make 3 types of rectangles. We did one really long one with 12 going across. We did one with 2 rows and each row had 6 going across. Then we did a rectangle with 3 rows and it had 4 going across. We're going to take a look at page 259, which came in your packet this week, and it says to use graph paper to make a rectangle. I know we don't all have graph paper at home, so I'm going to do it over here on the board and show it to you. So over here, the fact that it gives us says you can fill a rectangle with squares. All the squares must be the same size. All the shapes have to be squares. So we're going to see if we can make this rectangle using different size squares. So the first thing I'm going to do, I drew it twice over here. The first thing I'm going to do is divide this rectangle up into 3 squares. So I sectioned it into 3 squares. How I know it's a square, if you look at one, it has 2 little squares going across and 2 going down. So I know all the sides are equal. So I made a rectangle using 3 squares. But there's another way I could do this using different size squares. So down here, instead of splitting it into 3, I'm going to do it a little bit differently. This time I've split it into 12 little squares. So as you can see, we made the same size rectangle using different size squares. Down here it says to reflect and work with a partner, so you can work with somebody at home or you can just think it through on your own. And I'll pause the video here in a minute so you guys can have a chance to think about it or talk about it with someone, and then we will go over it together. So what you're going to do is you're going to pretend like you have 9 squares. So I just did an activity using 12 squares. So we're going to pretend like you have 9 of those that are all the same size. And it wants to know, can we make a rectangle with the squares in 1 row? Can we use 9 squares to make a rectangle with 2 rows? And can we make a rectangle with 3 rows if we have 9 squares? So right now you can go ahead and discuss that with somebody. If you're by yourself, you can go ahead and jot it down on a piece of paper, however you want to do it. But right now you can pause the video and you're going to pretend you have 9 of the same size square. Can you turn those squares into a rectangle with 1 row, 2 rows, and 3 rows? So you can go ahead and pause the video right now. And then when you come back, we'll check over this. Okay, now that you've discussed this or practiced on your own, I put 9 squares out in front of me. So the question asks, can we use our 9 squares that are the same size to make a rectangle? So yes, we can use our squares to make a rectangle with 1 row. So as you can see, I have 1 row with 9 squares the same size, and it made a rectangle. We know this is a rectangle because the top and the bottom are a different length than the 2 sides. Now it wants to know, if we use these same 9 squares, can I make a rectangle with 2 rows? So if I kind of mess around with these and move them around, you'll see that when I try to make a rectangle with 2 rows, I have 1 left over. There's nowhere for me to put this to make it a rectangular shape. If I try to put it at the top, it's uneven. If I try to move it at the bottom, it's uneven. So if we have 9 squares, we cannot make a rectangle that has 2 rows. Next, I want to try it with 3 rows. So if you look, I can rearrange these squares to make 3 rows, but the question asks, can I make a rectangle? So I have 3 rows, but this is not a rectangle. You cannot make a rectangle using 9 squares. The reason why is because what we've created here is another square. If you look at this figure, 1, 2, 3 going across, 1, 2, 3 going down, we have a square instead of a rectangle. So if you have 9 little squares like we just did, 9 squares, we can make 1 long rectangle going across with 1 row, but we cannot make a rectangle with 2 rows and 3 rows if we only have 9 squares. Okay, I'm on to page 263. This one's a little tricky, and it's especially tricky if you don't have graphing paper. So I figured we could do this together today. So number 15 on this page said Sue is making a mosaic design. She has squares that are the sizes below, but she can only use squares that are all the same size. So she has 3 centimeter squares, 4 centimeter squares, and 5 centimeter squares. She cannot mix and match them. They have to all be the same size. Sue will use the squares to fill a piece of paper that is 24 centimeters long and 12 centimeters wide. So we're going to do this together. I'm going to make it on my chart here, or my board that I have. So it says that it's 24 centimeters long. So 24 centimeters going down, 24 centimeters long, and 12 centimeters across. So this would be the size of her sheet of paper. Now it wants to know, can she use 3 centimeter squares to make her design? So I'm looking at part A. Can she use 3 centimeter squares to make her design? So how I would do that, 3 centimeter squares, that means that I would go 3 across, 1, 2, 3. I would go 3 down, 1, 2, 3. So that would be a 3 centimeter square. So let's see if I can go all the way across doing 3 centimeter squares. 1, 2, 3, and then 3 down, 1, 2, 3. And I'm just going to keep making my 3 across and 3 down. So we know that the 3 centimeter squares can fit evenly going across. Now I'm going to stop the video and I'm going to continue to make 3 centimeter squares going all the way across the paper, and we'll see if they will fit. Okay, so what I did was I used the length of paper that Sue had. It was 24 centimeters long and it was 12 centimeters across. And it wanted to know for part A, could she use 3 centimeter squares to make her design? So 3 centimeter squares were 3 going across and 3 going down. She could use those to make her design because, as you can see, it fit perfectly into the rectangle. There was nothing left over. So for part A, yes, she can use the 3 centimeter squares to make her design. And it says, if so, how many squares will she need? So this is our picture. We're going to see how many squares it took for her to make up this design. So she had 4, and then our next row makes 8. We're going to add 4 each time. 12 plus 4 is 16, plus 4 is 20, plus 4 is 24, plus 4 more is 28, and plus 4 more is 32. So it took 32 3 centimeter squares to make her design. Okay, we're on to part B. It says we're going to repeat what we just did, but this time we're going to pretend like she has 4 centimeter squares. So here's her paper. It is 24 centimeters going down. It is 12 centimeters going across. We're going to try to use 4 centimeter squares to figure out if they would fit inside of this shape. So to find a 4 centimeter square, we're going to count 4 across. 1, 2, 3, 4. So we need 4 in our row, and then our column also needs 4. 1, 2, 3, 4. So this is what our 4 centimeter block would look like. So I'm going to see if that will fit going all the way across. 1, 2, 3, 4, and then down. 1, 2, 3, 4. Okay, and let's try it up here. 1, 2, 3, 4, and then 1, 2, 3, 4. So we do know that we can fit our 4 centimeter squares going all the way across. So again, I'm going to stop the video and I'm going to fill our entire paper up with our 4 centimeter squares and see if we can use that to make up her entire paper. So if you look at what I've done, I've covered her entire paper with the 4 centimeter squares. So can we use 4 centimeter squares to cover her entire piece of paper? Yes, we can. And it wants to know how many squares will she need to do this. So we have 3 in each row. So we're going to add them up. 3 plus 3 is 6. Plus 3 more gives us 9. Plus 3 more gives us 12. Plus 3 more gives us 15. Plus 3 more gives us 18. It will take 18 4 centimeter squares to fill up Sue's paper. Okay, I am now on to part C, and it says that we're going to do the same thing we just did, which, by the way, if you look on your paper, this is what Sue's paper looks like. You can see that hers is 24 centimeters going across and 12 centimeters going down. Mine looks a little different, but it's the same thing. I have 24 centimeters going down and 12 going across, but if I simply just rotate my board like that, I have the same shape that they have on here. I'm just having my board turned this way. So for part C, it wants to know if we can use 5 centimeter squares now to fill up her entire sheet of paper. So if you remember, what that means is we start at the top and we have to count 5 little squares going across. 1, 2, 3, 4, 5. And we need 5 going down. 1, 2, 3, 4, 5. So our 5 centimeter tiles would look like that if they were on our paper. So let's look and see if it will fit. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, here's the problem. I can fit 5 centimeter tiles partially across. So let's look. These are my 5 centimeter tiles. Okay, so if you look, I'm able to fit 2 of them on going across. So I have 2 across, but if you look over here, I don't have room to make another 5 centimeter tile. I don't have room on any of them to go across enough to make a 5 centimeter tile. Also, if you look at my last column, 1, 2, 3, 4, I only have 4 going down. So we cannot fit the 5 centimeter tiles on her piece of paper. They're too big. There's not enough room. If I were to make another 5 centimeter tile, 1, 2, 3, 4, 5, and then 5 going down, 1, 2, 3, 4, 5, you would see it's completely gone off her paper. So for part C, it says that she cannot fit the 5 centimeter tiles onto her piece of paper. So that is it for today's lesson. If you have any questions, feel free to get a hold of your teacher or contact us to ask for help. I hope this answered some questions, and we will talk to you guys next time. Bye.